This will be for the con exercise, chain rule with tables. So you want to remember the chain rule. The derivative of f of g of x equals f prime of g of x times g prime of x. Okay, so you take the derivative of the outer function, you leave the inner function alone, and you multiply by the derivative of the inner function. All right, you sub in the value for x, you'll see that in the table, and yeah, just use the table given. All right, so here we're giving the table for x equals negative 2 and 3. We have our functions g and h and the derivative g prime and h prime. All right, and we want to find the derivative with respect to x of g of h of x at x equals negative 2. So clearly our inner function is h of x and the outer function is g. So in order to find the derivative, we said for a composite function, it's going to be the derivative of the outer, so that's g prime. Leave the inner function alone, so that's h of x. And that's going to be multiplied by the derivative of the inner. So that's going to be times h prime of x. All right, so that was the formula in the notes, just using different letters. So that's going to be g prime. And since we're evaluating at x equals negative 2, h of x is going to be h of negative 2. And that's going to be times h prime of negative 2. All right, and we have g prime still. And using the table, h of negative 2, if you go to x equals negative 2, and the h function right here, that's a 3. So h of negative 2 equals 3. And h prime of negative 2, once again, going to x equals negative 2. Here's h prime. And that's going to be a negative 5. So h prime of negative 2 is going to be negative 5. All right, again, going to the table, we want to get g prime of 3. Here's x equals 3. Here's g prime. So right there, g prime of 3 equals 1 times negative 5. And of course, 1 times negative 5 is just negative 5. Final answer. Negative 5. All right, so as always, we have our table for the functions f and g, and for values of x equals 1 and 2. Capital G is going to be f of g of x. We want to find g prime of 2. All right, so in other words, the derivative of this right here at x equals 2. All right, so the g function here, that's going to be the inner. And the f function here is going to be the outer. All right, like we said in the notes, it's going to be the derivative of the outer. All right, so that's f prime. Leave the inner alone, so that's g of x. And then times the derivative of the inner, that's g prime of x. All right, we're finding the derivative of this right here, which is considered capital G. All right, and we're doing this at x equals 2, so subbing in 2 in place of x, we have f prime of g of 2. And again, x equals 2, so that's g prime of 2. And that's going to be f prime. Finding g of 2, if we go to the table, here is x equals 2. Here is the g function. So that is just 1. G of 2 equals 1. So that's going to be f prime of 1. And g prime of 2, if we go to x equals 2, here's g prime. At x equals 2, that's just 0. All right, f prime of 1. Again, you want to go to the table. Here's x equals 1. Here's f prime. So f prime of 1 equals 3. And that's times 0. And of course, 3 times 0 is just 0. Final answer. All right, these are all basically the same. We'll do one more. Find the derivative of f of g of x at x equals 1. All right, the derivative of a composite function. It's going to be the derivative of the outer. So that's f prime. Leave the inner alone. So that's g of x. And then times the derivative of the inner. So that's g prime of x. All right, that's straight from the notes. So x equals 1. So we're going to do f prime of g of 1. And g prime of 1. That's going to be f prime and g of 1. Go to the table. Here is x equals 1. Here's the g function. So g of 1 is just 0. So that's going to be f prime of 0. Okay, this is not times 0. This is f prime of 0. Times g prime of 1. Here's x equals 1. Here's g prime. So g prime of 1 is going to be negative 2. Again, going to the table for f prime of 0. Here's x equals 0. Here's f prime. That's a negative 3 for f prime of 0. And that's times negative 2. And of course, that is just positive 6. Final answer.